All right, thanks everyone for coming along to my talk on Apache Gravitino. Please forgive my slightly croaky voice. I actually totally lost my voice yesterday, and there was a chance I wasn't even going to be able to give this talk. But thankfully it's become mostly good, and Mike's help. So here we are. So just first off, a little bit about me. Currently my day job is a community manager at Datastrato. I'm also a volunteer at the Apache Software Foundation, where I've done a lot of work over the last 15 years. I'm currently one of the directors at the ASF. I'm also the VP of the Apache Incubator. If you've been involved in any incubating projects at the ASF, I've probably reviewed your releases. I gave another talk about releases and license compliancing a couple of weeks back, and I checked how many releases I had reviewed, and it's more than 1,000. So there. Anyway, enough about that. What we're here to talk about is Apache Gravitino. And I'm just going to give you a quick overview, an introduction to it. And I'm going to show you some of its features, but not all of them, because we don't have enough time in the time that we do have. And if you can save questions to the end, that would be great. So let's get started. So what is actually Apache Gravitino? Well, it's a data lake, but it is a data lake of metadata. So what it does is that you can connect it to a whole lot of different data stores, and it will interrogate those data stores and find out the structure of the data inside there. On that point, don't think that it just deals with structured data. It can also deal with unstructured data as well. And once it's worked out that structure, it'll show you the representation of that data. And then you can then use that to do various things, which I'll get into. So you can think of it as a layer that sits on top of a whole lot of other products. We integrate with a lot of ASF products, such as Hive and Iceberg and Spark, Hoodie, and anyway, a whole lot of others. Talk a little more about them as we go through here. And then you can use that to either build a security layer on top of things or a data governance layer, or you can just use it to query between those different products. So when you're looking at modern data infrastructures, you often get these data silos. Because you're using so many products on so many platforms, and a lot of your time and effort is actually spent transferring data around. And that can be expensive. If you're talking terabytes or petabytes of data, moving that around is costly. So one of the things that Gravitino solves, by using the metadata, it can intelligently query these data sources and not transfer so much data around. It depends exactly on how you're set up and your data and all the rest, but in general, it means that you can actually run these queries without having to do that data transformation and data transfer parts. And I'll show you a simple example of that a little later. So the first thing it solves, being a metadata lake, is that you can point it at your data sources, and you can see the structure of your data straight away. The other thing that it will do too is, unlike some other data lakes, is you don't have to tell it the structure, it works that out itself. And if that data source structure changes, it automatically updates. You can also make changes to the structure, like you can add new fields, we'll add new tables, for example, and those changes will propagate down to the original data source. So you can also use this to query different data sources, and you can also do joins between totally separate data sources. And this, by using this metadata to optimize the queries, it gives you improved performance. And because it's a single layer on top of all these data sources, you can also use that to secure your data. So it uses Apache Ranger, if people are familiar with that, under the hood to be able to do that. You can also tag data, and that means that you can use it for data governance. So for example, you could tag the data at, say, a table or even a column level of what country of origin it comes from. And then when you run some queries, you can make sure that only certain countries' data is returned. You can also do it on a row level as well. So it's quite flexible in that regards. Now, as an open source project, we're not experts on all the various legislation around the world to do with data governance. So it just gives you a framework that you can build yourself and put on top of it to suit your solution. The more recent versions have actually focused more on AI data and managing AI data assets. So we have support for AI models and support for file sets, support for virtual file systems. So it will be able to read data that is, say, stored in S3 or any of those other cloud providers' platforms. And that's, you know, where we're going with it. So we've just graduated as a top-level project at the ASF. We've been in incubation for about 1 year. It's actually taken 2 years to go from a closed source project to being an open source project on GitHub, to being donated to the Apache Software Foundation, to becoming a top-level project. And I think that's pretty good progress. The latest release was about a month ago, which was version 0.9, and we've made a whole lot of improvements to the AI model and file set catalogs in there. We've also added a Gravitino virtual file system, which means that you can actually move your data around and just update that. It's like a symbolic link, basically, to it. And it just appears like a file system on your hard disk rather than something that's remote. We've improved the security continually in versions. We've also added support for data lineage, which is a feature that a lot of people have asked for, and that follows the Open Lineage API. And we've also put in a Helm chart and Kubernetes support. We're currently working on the 1.0 release, and that will be out in a couple of months. We tend to release every 3 or 4 months, but if you want, you can go get the latest code on GitHub. So I'm going to give a demo. Enough of these slides. What are we going to do here? So first off, I'm just going to show you the API. Let's just make this the right size. So this is the simple API that comes built in with the product. So if we go there, well, this is currently showing the. Actually, before I should tell you what I'm doing here. So we've got a couple of repos. One is the Gravitino repo itself at github.com/Apache/Gravitino, and the other one is the Gravitino Playground repo. And what this has is a whole lot of Docker containers that are set up with some test data. So that means you can just grab that, run it, and then you can get started to play around with it quite easily. So it's got Grafana, Hive, Postgres, MySQL, Ranger, Prometheus, Gravitino, Trino, Spark, and Jupyter in there. So all of this is running on my laptop here. Whenever you do demos, you pray to the demo gods, but even I'm not silly enough to try and have this all running in the cloud and then using the internet here to try and get it working, because I know that's just a recipe for disaster. So yeah, the playground comes pre-built with a whole lot of things in it, so you can easily run that up and just play around with Gravitino, and that's exactly what I've done here. So we've got this demo Metalake, and if we open that up, you can see that it has a whole lot of catalogs in there. So it's got a Hive catalog, an Iceberg catalog, a MySQL catalog, and a Postgres, and I'm just going to look at a couple here. So the Postgres catalog has a HR catalog in it, a HR schema, I should say, with some tables that are typical what you would find in a HR. And we can, again, this is just not storing the actual data, it's storing the metadata. So we can say, have a look at the employees, and you can see the rows in that employees table there, and they're typical things like an employee ID, a department ID, job title, name, date of birth, when they were hired, things like that. And we've also got a Hive catalog, and that has a sales database in there, and that's got things that are typical to do with sales. So normally Hive and Postgres are totally different data formats. If you were to try to do something with those two bits of data together, you'd have to move this data about and transform it in some way. So as well as having a UI, we've also got other ways that you can interact with Gravitino. So there is a REST interface, there is a command line interface, there's a Java API, and there's a Python API. So no matter how you normally work, one of those 4 things, or 5 things including the UI, should be able to suit your needs. So I'm just going to go show you the REST interface first. So I'm just going to copy and paste some commands here, so it saves me typing. So if we do a curl on the API and say /metalakes, that's going to give us all the metalakes, and that returns it in JSON style format. And you can see there that we have a metalake called metalake test, metalake test, and we have another one called metalake demo. Right? And we can go deeper and get more data than that. We can ask for the catalogs, for example. That's returning all the catalogs that are in the metalake demo. We could go deeper and ask for the schemas there. Again, that's returning all the schemas in the Hive catalog in metalake demo. And we can even go down to the table or even the column level there. So let's do that. So that's at the table level. So we're now seeing the tables in the sales schema in the Hive catalog. And we can even go and have a look at the columns in a table. So, right. It's a little hard to read on the screen there, but you can see that looks like columns, and you can see that it's got information about the columns, about what their data types are, and whether they're nullable, whether it's an auto increment, and things like that. So as well as, I'll just show you some examples for a different type of catalog. So this was a Hive catalog. So if we then have a look at the Postgres catalog, we can see that it gives very similar data back, even though they're totally different data formats. And again, we can go all the way down to the column level. Oh, whoops, made a mistake there. I'm not going to try and debug that anyway. So, but as well as just looking at the data, with the post interface, you can also create any of those entities that I just talked about. So you can create metalakes and you can create catalogs and so forth. I shall try. Sorry, I think I've already created one of that name. So let me just change the name and I'll do it again. Yeah, all right. And for some reason it's not working. As I said, it's always a bit risky doing live demos like this. But rather than try and work it out, you just trust me that this worked. I was playing around with it an hour beforehand, and that was working fine. Oh, actually, I see what the problem is there. So if we change that to, yeah, okay, let me just fix that up. So if we go back here, the problem is that I have this metalake test, but I've actually turned it off. So I'm going to turn it back on again. So that's good. So now that we have that, if I just run the same command again, it should work, but didn't. But anyway, I've been playing around with this a little bit, and obviously there's some issues there. But you can create metalakes and tables and catalogs and even alter tables as well. And again, any of these changes that you make to the catalog will be propagated down to the remote data source. So the changes go both ways. If any of say your Postgres database gets structure changes and new tables get added or tables get modified, they will automatically be represented in the Gravitino, and you'll be able to see that. Let's just have a look at this again. So as well as a post interface, a REST interface, there's also a command line interface. And if I do that here, you can see that's just putting out the help. And you can do all sort of the similar sort of things via the command line. So for example, I can list all the metalakes there. I can show me the details of a metalake, and that's just returning the comment that is associated with that metalake. And I can list all the catalogs. I can list all the schemas. I can, list all the tables. So you can see it's quite easy to integrate with and to do things like that. If you get the name of the thing wrong, it'll give you some error messages back. The error message could be a little more friendly, but they're mostly human readable. You can also, as well as just listing things, create stuff. So for example, if I create a new metalake there, and if we go back to the UI, that should, there we go. We can see that there's a new metalake there that's been created. It doesn't have any catalogs or anything in there, but we could go on and create catalogs and so forth in there. You can also create catalogs manually in the UI, and you can see that we support a number of different types of catalogs. So we support relational databases, and if we have a look here, you can see there's quite a lot of platforms that we currently support. So it's Doris, Hive, Hoodie, Iceberg, Payman, MySQL, OceanBase, and PostgreSQL. But there's also a JDBC driver. So it would basically support almost any relational database that supports JDBC with not a lot of work. As well as relational databases, we also support file sets. Currently that's just Hadoop, but we're adding support for other types of file sets. We also currently support streaming data as well, such as Apache Kafka. And finally, we support AI models. So let's go back to here. Oops. So when I created that metalake, if I just list the metalakes out again from the command line interface, you can see that the right ones are returned. And yeah, that's where I'll probably end that. So remember, as well as the UI and the command line interface, and the REST interface, there's also a Java API and a Python API that you can write code and do much the same things as that I've got here. The code also has other hooks in it as well. So there's hooks when things get created, for example. So you can, when a metalake gets created, you can make your code do things. There's also statistics available of what's going on under the hood and things along those lines. So the programming APIs have a little more functionality under the hood if you need that. So let's go back to my slides here. So that's a really quick overview of Apache Gravitino. I'm probably going to finish a little early as my voice is getting a bit croakier. So hopefully I've shown you all there that it's really easy to discover and query all your data in Gravitino. One of the things I didn't touch on there, I'm running this locally, but it is designed to be run on the cloud, and it's designed to have the data in multiple cloud vendors and also multiple regions. So I could have that Postgres database up on, I don't know, AWS, and then that Hive database could be in Azure, and I could do exactly the same things. That query might take a little bit longer because of the latency involved, but it would still be pretty fast and be able to do that. Actually, let me show you one other thing before I go on with that. So I'll show you some cross-join queries. So I've got here some SQL. We've connected to Gravitino here. And if I run this query, let me just find where the button is. Yeah, I can just do that. So it's already run down there. So there's nothing surprising about that. That's just looking at the sales and store table in Hive and just doing that's pretty standard SQL. But if you have a look at this next query here, you can see that it's using the Postgres HR database there, the Postgres HR database there, and it's using the Hive database there. So that's actually doing a cross-join between multiple data sources. And if I just select that and run it, there we go, you get the results back almost instantaneous. Now again, this is running on my laptop. It didn't have to go out to the cloud and do anything to do that, but you get similar performance to do that. And it can do, I mean, that's not a hugely complicated query, but that's quite an advanced query. You know, it's got averages and sums. It's doing a cross-join across multiple tables. It's doing grouping and ordering by. So you can see that it's quite fully functional in those regards. And, you know, we can even go and, you know, even do more complex queries. So this is the total value of sales, the number of sales by month for things that are expensive. If we run that, again, you can see the results come almost back straight away. If we want to see, you know, what products sold the most. Yeah. So this is just sample data that we've put together, that we've put in the playground, so that you can easily, you know, run through this yourself and have a good play with it. Yeah, so let's go back to that. So again, you can see that you can have your data on multiple cloud vendors and in different regions and run those sort of queries on there. As I've shown you, there's a REST interface, a command line interface, and there's also a Java and Python API. If you want to find out more about those, you can, if you go to the Apache Gravitino website, we have the documents there, and if you just click on the docs link up there, you can see that it has all the documentation there for the current version and previous versions as well, and it will have the Java API and REST API in there, along with examples on how to use them. I'm just trying to find an example here. Yeah. Anyway, there's lots of information there, so you can quite easily find what you need. So the things that you can use Gravitino for is solving data governance and security issues. Because it acts as a layer on top of all your other products, you can integrate everything together in one spot. So it can actually act as a single source of truth, and you don't have to, in a lot of cases, copy this data around. And you know what happens when you start copying data around is that you end up with multiple sets of the data, and all those are slightly out of sync with each other, and you end up with not having a single source of truth. Recent versions, we've added support for AI models and file sets, so you can manage your AI assets as well. We're currently a top-level ASF project. I said we graduated about a month ago, and as an ASF project, it is an open source project under a permissive license. It's free to use, and we have a growing community behind it. I was just looking at the number of contributors we've had to the project, and we're currently up to 197 contributors total. That's over the 1.5 years that it's been open sourced. So we're going to hit 200 contributors very, very soon. And yeah, so hopefully you're interested in it, that QR code just goes to the Gravitino web GitHub repo, where you can find a whole lot of more information about it. And on that, I'll open it up to questions before my voice totally disappears. So thank you. Yeah, a question.
I have a need for Postgres replication
Hmm?
failover. It sounds like the failover is very possible.
So Greg, the question was about Postgres and about using Gravitino for a failover. Yeah. Yeah, so it's probably not ideal for that because what it's doing is it's interrogating the Postgres database to get the metadata. So you would have the metadata, but you wouldn't have any of the data in the tables. So that's great if you want to fail over for the structure, but I'm assuming you actually want to fail over for all of the data. You could certainly create multiple data sources of multiple Postgres databases and copy the structure between the two and write SQL statements to do that, but I'm sure there's better ways of doing that in Postgres natively. It's got features inside it that do failover and yeah. Yeah, that's right, no problem. Any other questions? Yeah, up the back. The question was, is there any plans of expanding it into non-cloud data? Yeah, well, it supports virtual file systems, and it supports several types of those. So that can be either hosted on S3 or could be hosted locally. So the answer is, yeah, it can do that. So it doesn't have to be cloud data. And the same with the relational databases that it supports. Those don't necessarily have to be hosted in the cloud. They could be hosted locally or hosted inside your internal network or wherever. So it's pretty agnostic about that. The demos that I just showed you there, for example, everything was running on my local computer. So that's not the cloud. Does that answer your question? Thank you. Yep. What's the... So in terms of deployment, we've got documents on how to set it up and so forth. It uses a number of other open source products underneath the hood. It uses a custom Trino connector, for example. It uses Apache Ranger, but its footprint isn't that large. It may just depend on what you're trying to do with it. If you've got a large number of catalogs, and if, for example, part of the optimization for queries will only work if you've got Gravitino running on multiple nodes. So then you're getting into slightly more complex deployments to be able to do that. I'm not sure if that answers your question or not. It can be deployed on any of the cloud platforms. As I said, we've got a Helm chart and Kubernetes deployment as well, if that works for you. Yeah, so there's multiple ways of deploying it. The simplest way to do it would be to download the source code, compile it yourself, and then put it on an AWS box. It's pretty straightforward. Yeah, sure, go ahead. We've got some time. So it supports a wide range of things, but it doesn't support everything, obviously. So, and I'm probably going to miss a couple. It supports, as far as relational databases go, Postgres, MySQL, but it also supports any JDBC type database. So that's basically all of them. It also supports Hoodie, Hive, Hadoop, Iceberg, Payman, Spark. It also supports Kafka in terms of streaming data. And there's also a couple other ones that it supports, such as OpenBase. And there is another one, but I can't remember off the top of my head. I'm sorry, I can't hear you. Maybe ask the question later when I can. Yeah. Anyone else have a question? Yeah.
How does it compare to Apache Trino?
To Apache Trino. Trino does do some of this, and as I said, part of what we do is we have a custom Trino connector, but it has a lot more functionality that Trino does, and that it actually provides a layer on top of multiple databases where you can do, well, data governance, for example, is probably a feature that Trino doesn't really have. So you can example tag rows or columns or tables, and then you can use that tagging to implement various things such as data governance. You can also set up roles and permissions in this as well, so you can use it for security access. So you can do that across multiple data sources as well. Any other questions? All right, thank you very much for coming along and listening to me. I'm going to be here the entire conference, and as long as my voice holds up, come up and have a conversation with me. Thank you very much.